Hess's law questions in Module 2 of Year 11 Chemistry can get really complicated, so here are some tips and tricks to make sure you get it right every single time.
First thing to understand is that Hess's law is about finding the enthalpy of a reaction using the enthalpies of other reactions. So the first thing you want to look at in a Hess's law question is the equations with a given enthalpy.
So in this example question, you want to draw your attention to these three equations right here where the enthalpies are given to you.
Second thing is you need to rearrange your equations with the given enthalpies so that it turns out like your final equation. But because there's so many different chemicals in one equation, you want to look at the chemical that's not involved in any other equation so it doesn't mess around with your rearranging.
Considering this first equation, these three chemicals exist in other equations as well, so I don't want to look at those chemicals when I'm rearranging. In the first equation, the only chemical that's not in another equation is this one right here, so that's the chemical I'm going to use to compare to my final answer. KClO3 is on the left, whereas in my final answer I want it on the right, so I need to flip this first equation. When I do that, the sign on my enthalpy changes to a positive. Doing the same thing with my second equation, I can either look at it from K or from Cl2 because they're both not in any one of the other equations and they exist on the left as they should be, so I keep my enthalpy as minus 437. And looking at my last equation, Mg is in the first equation, MgO is also in my first equation, so I only want to look at O2. Comparing to my final answer, O2 is on the left, which is where I want it to be, but in my final answer it's actually 3 on 2, not 1 on 2. So I need to multiply my enthalpy by 3. Now that I've manipulated all my equations and my enthalpies, I can add it up to get my final enthalpy of this desired equation, which should be minus 391 kilojoules per mole.